Here we're going to look at reaction mechanisms and we're going to consider the following reaction. We have 2 molecules of nitrogen monoxide and 2 molecules of hydrogen gas. They're reacting together to form water vapor and nitrogen gas. It's highly unlikely that all 4 molecules will collide simultaneously with the correct alignment and sufficient activation energy to react. In fact, collisions of 2 or 3 particles are extremely unlikely. Instead, most reactions do not occur as a single step, rather as a sequence of elementary reactions. The overall sequence of reactions is called a reaction mechanism. So here, we're given the following elementary steps. It tells me that this is my slow step, so I can derive from here my rate law, because I can use my coefficients for my exponents. Because this is the slowest step, that means that it has the highest activation energy and will take the longest amount of time to react. So we can find a rate law as R is equal to a rate law constant, H2, the coefficient here is 1, so this is a first order, and the coefficient here is also 1. So it's also a first order. Now, when we're reacting H2 and NO, we have to make one of our products. So we either have to make water vapor or nitrogen gas. Here, we're going to react the H2 and we're going to grab one of the oxygens to make water vapor. So we have one of the 2 that we need in our products. Next, we have left over just 1 nitrogen molecule, so that's 1/2 of nitrogen gas. Since this was not what we need in our final, this is called an intermediate product. It's going to be used up and it's highly unstable, needs to react. So here I'm going to use it. I have to use it in my next elementary step. I'm going to combine it with 1 more nitrogen monoxide since my final answer has 2. When I do that, I create nitrogen gas and I'm left with 1/2 of oxygen, which is another intermediate. I use that intermediate with my last reactant that I need. I need 2 hydrogen gas molecules, so I can use that again, and I'm going to make 1 water vapor with that. When I add up everything here, I can see that my 1/2 of nitrogen gets canceled out because it's on both sides. My 1/2 of oxygen gets canceled out because it's on both sides. And I'm left with my target equation that I wanted to find.